Okay, so last time we were creating that data set, and so I went ahead and finished up creating, at least for the normal ranges that we got from all those laboratories.
Yeah.
So let me pull those up. And so there should be an Excel file and a CSV file. So we're going to pull up the Excel file.
Yes. The analyte data?
Yep.
Okay.
And I have the data as long format and as wide format as well too. And because wide format can get really messy with it, I separated it out as adult and child as well. And I figured we could just do a quick run through. I already did a run through of it, but just kind of go through the process of what's going on and seeing if we see anything that really stands out to us.
Oh, so you did all of the different labs that you wanted to look at, right? Or the ones that had like the data, the cutoff data?
Yes.
Or ranges, rather?
Yep.
Okay.
So here we have the Mayo Clinic, the LabCorp, and Benioff. I don't know if that's how you spell it. But one thing that we can do is I really want to let's highlight all these. So one of the things that we can do, and this is what makes Excel so nice, is that you can do this relatively quickly. And yeah, so let's do it on that. Okay.
I'm sorry, my dog is just going nuts.
Oh no, you're fine.
I don't know if you can hear him. Yeah, I don't know what his deal is.
Actually, let's do it. Let's swap that. Let's delete this level.
Oh, wait, do you need to share your screen?
Oh, am I not sharing my screen with you?
No.
Oh, I am so sorry.
No, it's okay. I wasn't sure if the recording was going to pick it up.
No, the recording will get it. It just won't get. You just can't see anything at the moment. So I'm so sorry.
No, it's fine. I was like, I just wasn't sure. I'm like, I think he's going to share his screen. I don't know.
Okay. So right now, I'm going through all the Excel data and I'm organizing it. So right now I'm going to custom sort and we're going to delete this level because I wanted first do it by age and then I want to do it by analyte.
Oh, okay.
Just to see if we can find any trends that are going on just by looking at it, and then we'll plot some stuff out and see if we can see anything. And we'll look at the wide format as well to see if we can see anything from that. Even though it's kind of the same thing, it's just slightly different.
Yeah.
Okay, so here we separated on adult and then on the analyte. And one thing that I noticed was that I think the Mayo Clinic has more, they screen for more stuff. And I think the Benioff screens the lowest. um, has the most missing values.
Oh,
And so like Benioff, NA, 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 NA,
yeah.
NA. So that's one thing that stands out to me. But the Mayo Clinic usually has um, something there. They have the most. The Mayo Clinic normally has values when the other ones don't. And
Yeah.
so,
Some of these ranges I feel like are quite, or I guess more varied than I would have thought.
yeah, and we'll look at that at the wide format because you can see it a little bit better with that. But yeah, there are some of them are kind of close and some of them are kind of all over the place. And so that's why I wanted to graph it out, was to see
Yeah.
how those were. And so, um, yeah, let's see if we can find one where the ranges varied a little bit. Yeah, so like with this asparagine, like the minimum cutoff for Benioff is 15 and the upper is 40. But then for LabCorp, it's 20 and then 106. And then for Mayo, it's 25 and 91. And
Yeah.
a part of me is wondering if that's due to the methodology or if it's due to um, like who's picking the cutoff points for those.
Well, the other thing I had a question about is when they say child, what do they mean by a child? Do they mean like newborn to, you know, 10 or 15 or 18? Like, are there different um, definitions of a child?
Yeah,
Like, is
so
that?
I think for the Mayo Clinic and Benioff, no, the Mayo Clinic and LabCorp provided. Let me look at it really quick. Yeah, because the Mayo Clinic did it from less than 24 months, 2 to 17 years, 18 years or older. And so for the child, I did less than 24 months, so it should say newborn, but um,
Oh, okay.
uh, so I did less than 24 months, and then over 18 years, I said was adult. But there was one of them where they listed it as child and adult. Yeah, so it was the Benioff Children's Hospital. They just
Hmm.
listed it as children and adults.
Oh,
And so
maybe
that,
that's why there's such a big variation with them.
yeah, maybe. Um, but when we look at some of these, we should be able to. Well, I was hoping when we graphed them out that we could see some trends that happened. Um, and we'll take a look. Maybe you can see something that I don't. But yeah, the lab core does it from 0 to 30 days, 31 days to 23 months, 2 years to 15 years, and then greater than 15 years. And so it's, as you said, it's tough because their intervals are so
Yeah.
like different with each other. And so I don't know if we can make a very good comparison, but I tried to pick roughly what they would be. So,
Yeah.
or what I would think. Yeah, so for the wide format, so that way I wouldn't have to have four different graphs. I included in here the min and the max
Hmm.
um, values for those. And as you said, there's some of them that had quite a big range. So like LabCorp, like here it's 121, 571, and then here it's like 200, 450. And so There's a lot of things like that, and there's a couple of them where they're mostly NAs. So the carnosine, I wouldn't. I would probably throw this out.
Yeah,
Um,
because you can't compare against a single lab.
yeah, like something like this probably is not gonna make a big difference, but depending on the harmonization level or the scaling techniques that we use, we might have to throw out a bunch of these that are missing them. We either throw out the lab that's missing it, or we throw out the analyte. Um, and I think at this point, I'm thinking the analyte. So like this one is 1-methylhistidine, like only the
Yeah.
malonyl does it. Um,
Oh, you have a lot. You have a couple of them later on down. Yeah.
yeah, yeah. These last ones are they're missing a lot. So, oh, sorry. Yeah, we're. I'll probably go through and just pick out the ones that have everything in them, depending on the harmonization method. And sometimes, if you have a pretty robust or big data set, you could fill in the missing data for those. And so, like in theory, we could take the means of the min and max right there, and then
Oh, yeah.
put them in there or something like that. Um, but it's not. I don't know. I think at this point, because we're trying to scale the data, I don't want to. I would rather not have it than have it. And
Yeah.
so, but you can see here what what's crazy is that we have some of these that are really high, or like there's big ranges for them on stuff, and then some of these they're like almost right on the money with each other.
Hmm.
And I'm wondering if maybe they were rounded or something differently, if they would came out the same. So this is 0.1 and 9.6 and 0.0 and 9, 0.3,
Yeah.
4.3, 0.5. Like those are right within range of each other.
Right.
But then some of them, they're just all over the place. Like this one, like glutamine. Like the lowest is 264 for the min, and the highest is 420. And then it goes to 730 and 1020.
Yeah.
Like, and so I'm curious, like how much some of these differ with each other. Because then,
Well, okay, so look at hydroxyproline. So for Benioff, it's 0 to 5, but then LabCorp is 19 to 115.6, and the Mayo is 8 to 61. That seems like what the heck is going on there?
yeah, I don't know. Like, yeah, and they didn't have the adult one for hydroxyproline for adult for Benioff. So yeah, I don't know. It's kind of all over the place when I was looking at it, and I couldn't really see any trends just by looking at the numbers like this.
Hmm.
I could see like you kind of see trends with the missing data and who has the most and stuff, but we can figure that out in pandas
Yeah.
anyways. And so, but yeah, it's just a little crazy, like how because it seems like the bigger numbers, it like because like in archery or shooting or something when you do a little bit of an angle change like at the when you only go a short distance it doesn't really make that much distant difference, but when you go like a really long ways that little tiny angle change can have like a huge impact on
Hmm.
where it ends up going. I kind of feel like that's what's going on here is that the smaller values are usually within like because you look at alpha amino and butyric acid, like the smaller values are all within range of each other. I would say that's not, and as some of the other ones we showed, like they're pretty close. Like, but then once you start getting to the bigger values, then they're all over the place.
Yeah.
And so yeah, but that's just kind of what I noticed uh, going through these. And so then I wanted to graph some of these and do a little bit of data verification and cleaning and graph them out. And then we'll make the toy data set here in probably next time. So the first thing we're going to do is import pandas as PD. Oh, kernel's still going. Gotta give it a second. Okay, let's import numpy as MP. Let's import matplotlib.pyplot as PLT. And even though I don't think I originally used Seaborn, I'm going to import it in anyways. Just on the off chance we need it. I already have it loaded up. Okay, so the first thing we're going to do is we're going to read in the CSV to there. In this one, I have it as analyte data.csv. First thing I always do before I start doing any type of analysis is I'll do head, see what my column names are, see what how the data is formatted, where the names are the names written out, and so that way I can kind of see what's going on here. And just kind of get a visual of what's happening. The next thing we want to do is I want to know what are all the unique classifications for a bunch of these columns, particularly for analyte, lab, and age. So the first thing I'm going to do is we're going to look at the age. And the way we're going to do that, we're going to do age dot unique. And then we're going to do that for the three other columns. Let's do it for the lab. Let's do it for the analyte. And were you able to load that up okay, Nicole?
Yeah.
Okay. Okay, so looking at this, what is something that pops out at you?
Um. Oh, with why are there two? Oh, with Mayo, I guess there's a one with a space and one without.
Yeah, so we're going to have to fix that.
Yeah.
So, because it's going to think it's its own separate one. So the first thing we want to do is we want to kind of figure out how many of them are there that we're going to fix and make sure that we can actually pull them out. Okay. Okay, so it looks like the majority of them have the regular mayo. Let's try it with the space. And there's two that have the space. So somewhere when I was entering these in, I accidentally put a space in. And so the way we're going to do that is we're going to say df equals df dot replace. We're going to say mayo space. Then we're going to replace those with mayo, no space. And then because we want to make sure we actually fixed it, we're going to reprint this out. Put it on there. Run it. Okay.
Yeah, so now it's fixed, right?
Yep, now it's fixed. Um, so then the next thing we want to do is, or one thing that you can do, um, and I kind of debated about this if this is the way I wanted to go, and I ended up not, but I figured I would include it in because it is kind of nice to know. So one of the things that I wanted to do, or I originally explored, was besides having a separate lower limit and an upper limit, I was like, well, what happens if you can make a list of the XY values so that way it's just one column with each other? And so if you want to combine two columns like that, this is the methodology that you would use. df.lock. And so lock, um, within pandas, if you want to locate something, there's two different ways to do it. You can either do the normal location, which goes off of strings, or you can do ilock, which or integer location, and that one goes off of sort of like if you wanted to, if you had a string, um, like hello, and you wanted the third one, it's technically fourth. It'll give
Mm.
you the L. That's you can just move it around. You can select things based off that same type of um, selection. I can't remember what that's called. um, but we're gonna just do location. So we're gonna create temp data, just a place to do it. And we could have done this all in one line, but I'm a big believer in separating out my steps, so that way I don't I can follow it again when I forget. Um, and so the first argument it's going to take is it wants to know how many rows we're going to want to collect from, and we want everything. So we're just going to put a colon right there, and then put a comma. And so that's saying we want everything. If we wanted the first five, then we put 0, 6, and it'll do the first five. But we want everything on there, and we want to combine them all. And then we're going to select, we want everything from there, and we want the lower limit, and then we want the upper. And we do the upper limit, and then we're gonna print out temp data to make sure it works. Oops. Let me see where I want. Oh, I misspelled something. There we go. So now we just have data of the first of this column, the lower limit, and the upper limit.
Mm.
And so the next thing we're going to do is we're going to create a new column and combine these together. And that column will now be a list of these two values together. So the way we're going to do that is we're going to call our data frame up, and this one, as I said, range. And then we're going to say that is equal to temp data, since we created it. We're going to select all the values, and we're going to say toList. So we're going to have it combined together into a, like two columns together into a list. And then we're going to verify that actually worked. So we're going to say printdf. We're going to do range. And then I want to make sure that we actually have values for all these as well. And so what we're going to do is we're going to say for I in range length child. Oh, we haven't separated those out yet. Never mind. I'm looking at. Let's just make sure these work. I'm getting ahead of myself. Okay, so now if we print the range, you can see now these two
Okay.
columns are now combined into a single column as a list. So now if we wanted to pull the first one out, range, let's do iloc 0, 1. Should print it out for us. Yep. So, but if we wanted the first element of that, just the 200, that should have worked. There we go.
Yeah.
So, yeah, so that's how you would do it. Okay. Another way we could do this too is there's a function called the group by function that's really helpful. I do it a very inefficient way, but I like to break everything down into its base parts and handle them as all separate variables. And I know every data scientist out there is going to be cringing at my methodology because there's such a faster way to do it, but I prefer this. So one way we could do it, I'll show the group by. So we'll say df group. And what the way I name my variables so people can understand is whenever I do any sort of transformation or I pull data out of it, I always add a new underscore to it. And so here I'm doing a group by. And so I'm saying the original data frame name, and I'm saying group. And so that way I know if I'm looking at that variable, oh, that one has had group by done to it. And so that way I can kind of keep track of what's going on. So group by, and then let's do it by, actually, I don't think I have a group by in my notes. Let me make sure. Yeah. So let's just look up pandas group by. It's not that difficult. But you can select it. Basically how we did with that Excel sheet, how we said sort and filter, and we could select on which columns we were doing it on. So if we select here, we select, all right, first do it by age and then by analyte. Group by does the exact same thing with that. Okay, so we're gonna want, yeah, I was right. Okay, so let's just group it by lab. And yeah, let's, should work. And so if we print this out, you'll see that it now becomes a different type of object. And so this is a group by function. I think if we don't do the print, there's a way to show it. I know, this is why I never do it. Let's just do this. Let's sum these up. There we go. So here we summed up, so it went ahead and summed up each of the columns. And so I said Benioff, LabCorp here, and it added up all the values. And so you can see that LabCorp had the smallest, just summing had the smallest limit, overall limit, followed by Mayo and then Benioff. But we know that's not entirely accurate because the Benioff seemed like it was missing a ton. And so one thing that we could do maybe if we say the mean instead, that might be better. Yeah, so looking at this, we can see the Mayo Clinic had the lowest limits, Benioff had the highest, and then the Mayo Clinic generally had the smallest upper limit as well. But that could be off because we need to get rid of all those NAs. And I'm not really inclined to do that at the moment. But there's a function called drop NA that you can use. And maybe we can just do that really quick. Drop NA should work. Okay. Yeah, so it should have dropped all the NAs out of there. You could see it didn't change it that much. So they're all about the same. Okay. And then let's hurry and do some plotting. Well, so the next thing I kind of do is and for the interest of time, I'm just going to copy and paste some of my notes into there, is I separate, as I said, I separate everything out. And as I mentioned, this is not a great way to do this. But it's the way that I feel comfortable with and I really like because it's nice to me. It's nice to have everything compartmentalized and I can go through and be like, oh, this is only that data set and of this particular thing, and I can pull it out and not have to worry about having to rewrite functions all the time. I just do it like dissect everything once and then I can run my functions on it. So you can see here my naming convention again. So I said child, so now I separated um, the ages from child and adult. And so we have child DF, adult DF. And then we have, then I separated out by lab. And so I took that separated out data frame, so child DF, and I separated out by lab. So here I said Mayo, I said Benioff, and then LabCorp. And I did the same thing with the adult. And so I went through and I selected each of those different labs. And so now I have a variable for each of these different, I guess, different cohorts in essence. And I like to print out, and whenever I do any sort of transformation, I always print everything out. So that way I can verify that I actually selected what I wanted to and I didn't have any mistakes. So here I printed out adult LabCorp. And so everything on here should be LabCorp and adult. So I just do a quick visual inspection and it looks like it did it correctly. So I'm just going to assume that the other ones did it correctly as well. And if something pops up, I'd probably go up here again and verify that they did, but that's the way I would do it. And then I went ahead and I separated out the min and the maxes as well for some of the stuff I needed for the graphing. So here I have, this is how I got the min values of just that column. And so I said here, I was like, so here it's the minimum value, it's a child, and it's from the Mayo Clinic. And from there, and to get that is I pull out the column, and so I said child DF Mayo, which we selected out of here before. And I selected the lower limit column, and then I transfer it to a list. Because if you don't do that, it treats it as a data frame. So if we were to copy that, um, it still thinks this is it, since I ran that. It's still treating it as a data frame. You can see the index right there. But when you put it to a list, now all of a sudden it's a list of all the different values. And so then I did the same thing for the max. And the way I usually do this is Jupyter Notebooks has a very nice feature where if you hold the control button, you can highlight multiple lines at the same time. And so I copied and pasted them in, and I went through and I deleted and then typed in max. And then I went over here and I did the same thing as I removed all the lower limit, erased it, and wrote upper. So that way it's pretty easy to get. And so then I have lists now of each of these. And these are a lot of different variables to keep a hold of, but it was nice to have because now when I go to graph, it just makes my life a little bit easier to do that. And so the first graph I looked at was min child Mayo. So that's our x values. So those are all of our x. And so this list of x values are right there. And so now these are going to be our y values right there. Is where I say the max child is going to be our y. And we're going to do a scatter plot and we're going to plot these out and see if we can find any trends with it. I want this to be, this is the shape of the point that's going to be on there. I want this to be red. And then we're going to put the label on there. We're going to say this is male. So that's the label associated with that. So I'm going to okay, so here's a nice instance of okay. Let's do a triangle. Let's do this blue. Let's do black core. Let's do this green. Okay, let's add the legend in there. And let's add X label. Let's name this min value dot X label max value. So this is for the child, so I'm going to put in the title. I'm going to say child. Okay. So kind of what we saw before is kind of how I said with the arrow analogy, you can kind of visualize that here. And so everything close together, it doesn't really make that much difference, but as you get to the bigger values, they spread out from each other more. And if I had to say which ones were the closest together, just by looking at this, and we could do a Euclidean distance and see which ones are the closest together um, to get like an actual number. But just looking at this, I would say the green and the red are pretty similar together. So the Mayo and LabCorp, but Benioff is kind of in its own little world there. And this graph's a little bit misleading too, because if you look here, the Benioff has lower limits. So if you look at these points right here, you can see it has a lower max value, but it seems to have higher um, min values. Oh, that's why we're on that. I was like, that's not looking right. So it seems to have their minimum values seem to be higher than the other ones, but their max values tend to be lower. And so their range that they're actually, their normal ranges are a lot tighter. So they're up, up above zero and lower than they go. So anything outside that range they would consider abnormal. But Mayo and LabCorp seem to have it um, where they have higher ranges of zero and bigger values that they go for, that they're considered normal. So that graph was kind of informative a little bit. And so we can do the same thing with the adult. Let's copy and paste that. I'm just going to do the control again. Erase child, adult. Change this to adult. Okay, so here's the adult values, and you can see they're a little bit more messier than the children's were. The children's seemed like they followed a pretty clear pattern, but the adult values kind of were all over the place a little bit, and I don't think we could really give any clear trends. But there's loosely Benioff is kind of following that same trend as we saw before, but not as strict as it was. So yeah, but once again, you can see all those other, like the smaller values, all seem to cluster together nicely, but as you get further apart, they kind of separate with the adults. All right, so my first approach of of doing this was I was like, oh, well, pandas should be able to figure out I want to plot some of these and have them. I want on the x-axis, I wanted each analyte, and then over each analyte, I wanted the Mayo, Benioff, and LabCorp to see how that graph came out. And so I here's my first approach, and I won't type it out because it didn't work how I thought, but I'll give you my the reasoning behind it and why it didn't work. And so I'm selecting out the child data, and out of there, I just wanted to practice just to see what would happen if I graphed the alanine. And so I located it. I pulled out the analyte and the lower limit because I just wanted to plot those. And when I tried to plot like that, it was not what I was expecting. And I'm not quite sure where it got some of those numbers because there should have only been one number for that. So I was like, well, that didn't work. And so the other way to do it is this other approach. And I wrote a simple test script for me to figure it out. And so here I have for the x, I have like 1, and then for the y, I have different values. And I originally tried it with that, and I seem to have better luck. So here, actually, we don't even need that one anymore. So here I'm plotting out same x, and so 2 and 4 will be on top of each other with RNG with the label. Um, and so I did that with 2 points on 2 and then on 3 to see if I could get them to stack on top of each other. And it seemed to work, so I decided to take this approach, which is why I like separating all my data out, is because now my data is already separated and I can